All right, quiet, please. Get those notes out.
I don't have notes. Baby Mult, what did you say? Baby Mult, what?
Thank you, Bella. Thank you, Haley.
Corbin, shut up. No. Oh,
thank you, Brock. Thank you, Paul. Here, Jenna, thank you. Thank you. Thank you. Thank you, Sam. Thank you. All right, here we go. Quiet, please. We are multiplying and dividing fractions today. We're going to go real fast here to give you the most amount of time to work. So please pay attention and follow along. All right. We were adding and subtracting fractions last week. Adding and subtracting is super duper hard. Multiplying and dividing, super easy. For those of you that are looking at your Chromebooks, please lower your screens. You should be looking at your notes. Lower your screens.
Corbin, lower your screen.
Thank you.
Probably a minor.
Corbin, lower your screen. I don't care. Just lower it. You don't have to shut it. Just lower it. Thank you. We are multiplying fractions, which is super duper easy. First, we may need to convert. So step one, maybe you need to convert into improper form, which turns out to be pretty an easy step. And then how do we multiply fractions? Super easy. No, you do not. Multiplying and dividing is super easy. Multiply straight across. All right? Then the last step is reduce. And you are welcome to use your calculators, ladies and gentlemen, particularly for numbers that are larger than 12, because you just had to memorize your 12 tables. So if you have something bigger, numbers bigger than that, feel free to use your calculator. So number one, we are just multiplying, and we do not have to convert. So we are just going to multiply straight across. 1 times 4 is 4. 2 times 5 is 10. And we need to reduce, which of course both of these will divide by 2. So that's really easy. 4 divided by 2 is 2. 10 divided by 2 is 5. All those numbers, Gabe, all those numbers were less than 12, so really good to do in your head. We're going to skip down to number 5. Attica, did you have a question?
Yeah, what are you listening to?
I'm recording.
Oh, good. Why are you recording?
Because I forgot to do it earlier, so we're doing it now.
For what? Do you have a YouTube channel?
I do.
You actually?
Yeah.
Wait, what's your name? I want to follow you.
Amanda Goodnow?
Okay. Shut up, guys. Hey, guys, I'm back.
All right. Number 5. We have a mixed number here, which we need to convert. We are going to multiply and add And do not forget your negative. That negative is going to come along for the ride. Gabe, this is the second time I've asked you to be quiet.
He's literally calling me names. Don't blame it on all their names.
Hey.
Oh, Corbin. All your other topics. Shut up.
1 times 3 is 3, plus 1 is 4/3. So that converts into 4/3 with a negative. And we're going to multiply by 1/2. So then straight across, negative times positive is going to give me a negative result. 4 times 1 is 4. 3 times 2 is 6. And again, both of these divide by 2. Negative 2/3 is the answer. Fully reduced. All right, my second fraction here, again, I need to convert it. The first fraction is going to come along for the ride. We have negative 2/3 times. And I want to bring down my negative from above. 14/5 is correct. We're going to multiply. 2 times 5 is 10. Plus the 4 gives us the 14/5. Now this one, again, is, okay to multiply. But I'm going to use my calculator because I can. Negative times negative is going to give me a positive result. And 2 times 14, well, I could have done that in my head. That was 28. And 3 times 5 is 15. Now, maybe I don't know if that needs to reduce. Can I use my calculator? Yes, I can. So 28 divided by 15, and math frac, we get 28/15. That is fully reduced. Multiplying fractions is easy. We go straight across. Now, for dividing, we have instructions here, but they're very, very wordy. So I'm going to simplify. We want improper fractions. That means maybe we need to convert to improper, which is fine. Here, number 2 says change to multiplication and flip the second fraction. What do we know that as? Keep, change, flip. Yes, keep, change, flip. When we divide fractions, we don't like doing that. We're just going to go ahead and keep, change, flip. Then we need to multiply straight across. And the very last thing is reduce. All right, so for dividing fractions, keep, change, flip is the big thing. And reduce, reduce, reduce. Let's turn the page. We're going to do a couple more. We are almost done. Number 9. I see a division symbol. I don't like dividing by fractions, so we are going to keep, change, flip. Keep the first fraction, negative 4/7. Change to multiply, and flip the second fraction. It's going to flip and become negative 9/8. So keep, change, flip. And then we can multiply straight across. Negative times negative is going to give me positive. 4 times 9 is 36. And 7 times 8 is 56. And maybe I don't know if those reduce. So I'm going to use my calculator. 36 divided by 56 and math frac it. It turns out it's going to give me 9/14. So that actually reduces to 9/14, which turned out was a divide by 4 top and bottom. There's your final answer, 9/14, okay? All right, number 11. Shh, Robbie, turn around. I wasn't talking to you. We need to convert this mixed number into an improper fraction with a negative. 7 times 4 is 28, plus 2 is 30. Multiply and add. Over the denominator of 7. I have a division sign, and I also need to convert the second fraction. Multiply and add. So 1 times 3 is 3, plus 1 is 4/3. Now, I don't like to divide by fractions, so instead we're going to keep change and flip the fraction. I'm going to keep the negative 30 over 7. We're going to change to multiplication, and I'm going to flip the second fraction. It's going to become 3 over 4. Now, I can multiply straight across. Negative times positive is going to give me a negative result. 30 times 3 is 90. I could use my calculator if I wanted to. 7 times 4 is 28. Do those reduce? Yes, they do. They absolutely reduce because they're both even numbers, so we get 45 over 14 with a negative. 45 over 14 negative. Okay. Last two, 13 and 14. Quiet, please. Number 13. The Statue of Liberty is 305 feet tall. A nearby building is 4/9 as tall. Find the height of the building. It's always kind of a challenge to know if you have to multiply or divide. So I'm going to simplify. I'm going to simplify and say, let's pretend I'm 6 feet tall. And if I said that one of my kids was half as tall as me, if my kid was half as tall as my 6-foot height, how tall would my kid be?
You are not. I'd be like 6 or 7 feet.
3. They would be 3 feet. So, if I am 6 feet tall, and I said that my kid was half as tall as me, what operation, if we add, are we multiplying or dividing that 6 and that 1/2 to get 3?
That would be very interesting.
Dividing by 2 or multiplying by half. This becomes, if we multiply by a half, we would get 6 over 2, which is 3. So, on number 13, it says the Statue of Liberty is 305 feet tall, and a nearby building is 4/9 as tall. We multiply those together, so we're going to do 305 times 4/9. Now, when we're working with fractions, I want everything to be a fraction, so I am putting a 1 under it. Can you lower your screen, please? Thank you. All right, and then we are going to multiply straight across, and I'm absolutely going to use my calculator because I have no idea. 305 times 4 is 1220. And 1 times 9 is 9. And I'm going to go ahead and use my calculator to reduce. So I'm going to divide by 9 and try and math frac it. And it turns out this is reduced. This is about 135.5 feet. That's what that means there, that decimal. That other building is a little less than half as tall as the Statue of Liberty. About 135 feet. All right, last one. Number 14. Sarah has 27 feet of wire. That's about the length of this room, 27 3/4 feet of wire to make beaded necklaces. If each necklace takes 1 2/3 feet, how many necklaces will we make? What operation do we need to do to figure out how many necklaces? I'm sorry. That's really immature. All right. So, if, I'm going to make the numbers easier. What if we had 30 feet of necklace and each necklace took 2 feet? How many necklaces would we get?
15.
How'd you get 15? You divided. You did 30 divided by 2 and got 15. We're doing the same thing here. We have 27 3/4, and we need to divide by the 1 2/3 to figure out how many necklaces. And of course, we're going to need to convert first. So I'm going to multiply and add to convert these fractions. 27 times 4, I have no idea what that is. 27 times 4 plus 3 gives me 111 over 4. 1 times 3. You can throw that away or stop. Then stop. All right, and we get divided by 1 times 3 is 3, plus 2 is 5/3. All right. And I do not like to divide by fractions, so we are going to change flip. Gonna keep the first fraction, change the symbol, and multiply by the second fraction. And then we can multiply straight across. 111 times 3 is 333, thank you. And 4 times 5 is 20. Girls, stop.
Girl, please do not assume my gender. Shut up.
All right, 333 divided by 20. Math frac does not reduce. Oh, wait, yes it does. No, it doesn't. No, it doesn't. Does not reduce. It is lowest terms, 333 over 20. So it turns out that she could make a little over 16 necklaces with a little bit of wire left over. Okay? All right, ladies and gentlemen, you have 2 choices for work practice today.